So this guy here is a very early hard drive. We have people that come from all over the place to get their picture taken with serial number 1 Bridgeport. So we come into our consumer culture world. We now start manufacturing sewing machines, typewriters, kitchen gadgets, all those types of things are starting to be manufactured now. This is one of the first practical sewing machines that was also created here. So we'll fast forward a little bit further now into 1890s, early 1900s. Pocket watches become all the rage. And pocket watches need lots of little screws to be put together. So this first machine we have here is a screw machine that was built primarily for making watch screws. Coil, stock, wire stock would be fed in. It would be worked on down here at the spindle end. An arm would come in, pick it up, take it over, slice the screw to put in the head of the screw, and then drop the screw down into this little bucket that's here. A couple things to note, this machine can make up to 10,000 screws per day. It's also one motor again. So you have to convert rotary motion into linear motion. So this machine uses an awful lot of cams and cam followers to operate. This machine is a horizontal thread mill that just came to us from Southern Gear down in Miami. A piece of stock would be put between the centers and the spindle. This is a thread form cutter, and everything would be in sync, and they'd cut the thread in a horizontal mode. This machine is probably from around the 1930s that came here. If you need to make bigger parts, you just make bigger machines. And you'll see 2 more examples of turret lathes. They're fairly large, but again, they're still one tool on one spindle. Back in this corner, we have some miniatures that were manufactured or built by John Oshauer, who spent a great deal of his life making them. So there's lots of different ones here, and there's a lot of different ones there. Some of them do work as well, but it's interesting to see, again, somebody spending time in craftsmanship making miniatures. So, as I said, a lot of companies left Windsor and moved to Springfield, Vermont, mostly because there was better water power. But there was some companies that also formed up there. James Hartness came along and worked on an optical comparator. Screw threads are pretty complex in shape. So we wound up measuring screw threads optically. It was one of the first uses of optical comparators, was to measure screw threads to make sure the angles were correct and the pitch was correct. We come down on this side of our museum, and again we see bigger machines. This is a Gridley automatic lathe. Again, the idea was one motor driving, and then use of cam followers and cams to turn rotary motion into linear motion. They did, this thing was just cutting off blanks for screws probably, but another machine. Another company from Springfield, Vermont was the Bryant Grinding Company, Bryant Chucking. This is an ID and OD grinder from about 1930, 1922. So gives you some idea. Frank Cohn developed Cohn-O-Matics. And the big change here now, when we just talked about turret lathes with a single tool on a single spindle, he envisioned multiple spindles and multiple tools, and all the tools would come in at one time and act on each one of the spindles. So every rotation of the spindles would give you one complete part. So it was very fast, mostly for high volume. They were making like fittings and so forth. But this really opened up to what you start seeing as automatic screw machines today. As we turn around, we see an old stable of every machine shop around, and that's a Bridgeport milling machine. Well, This guy's claim to fame is that it's serial number 1, made in 1938. So we have people that come from all over the place to get their picture taken with serial number 1 Bridgeport. But we're very proud to be the owners of it and the keeping of Bridgeport number 1. So we have to start going back now and bringing this story together. So let's take a look at our Bridgeport over here. We saw how parts were all made by hand, then they went to pattern following. Now we've got to convert the shop into thinking about how do you make it through automation. So companies, because there was so many Bridgeports out there, companies started adding these black boxes that you see there are retrofits. They were now able to demonstrate to the small shops that had all these Bridgeports that there was a better way than cranking handles. They can now program the machine. You had conversational controls on them, made it very simple for them to program, and that's the first step into CNC and NC control that we have. That machine then morphs into what you see here. And this is a vertical machining center from Haas. Haas was gracious enough to donate it to us, as well as Midaco donating the pallet changer. And something new, Chiron Engineering donated a vibration sensor for early detection of failure in the machine. So anyway, it's a little widget that gets machined on all sides and then it falls out in the middle. So during the summer months, we have interns that work here, and interns get to operate the machines. They get to understand the controls. They get to do lots of things in a hands-on environment. We usually get them from the local tech schools. They're either junior or seniors in the school, so they've had some exposure to manufacturing. I can't stress enough that our goal here is to inspire the next generation of maker, inspire and engage. We really feel if we get them early, we'll predisposition them, young people, for careers in manufacturing. We focus on 4th grade through 7th grade, so that when they get to high school, they can say, hey, you know, I remember I had a really good time when I was at American Precision Museum, learning some STEM kits and STEM skills. Maybe I should take that tech course in high school, or even further on and take more courses in manufacturing. So that's really our goal. You know, we have a mission, we have all those good things, but focusing on that age group and really inspiring and engaging that next generation of maker, that manufacturing offers great careers and great jobs. So we have another probe here on the machine from Renishaw. This probe, again, what we talked about, we have to get the human hand off of the process in order to create precision. So this probe is going around and checking the height of parts, finding part 0 on each individual piece, and that again takes more human error out of the equation. So the blue sensor that you see in the middle is from Chiron Engineering. It's measuring the vibration in the spindle so that if a tool goes dull, the vibration goes up, so we can change the tool out early before the part is destroyed or something else happens. If a part is loose, it goes through there. So it's not always about the modern machines. We also like to look at what I would say are workhorses of the industry. Fellows gear shapers, I'm sure there's numbers of them out there that are still running today, but we manufacture a little gear, and we'll get this guy started, and you can see this machine is from 1943, 1944. It's a gear shaper. It's going up and down there, cutting the teeth of the gear, moving in multiple directions at the same time. Again, during the summer months, we have inserts here. We actually make the gears from gear blanks. So this is kind of a fun place, and we call it the Innovation Station. And it's really great experience for kids to see how parts were made. So this was down in Springfield, Vermont, where it was made. I did have the great opportunity to meet I guess it was the grandson or the grandchildren of, might be the great-grandchildren even of fellows. they learned a lot about their family's history by coming here. So that was quite an exciting time as well for us here. So to see more on this machine and other machines, tune in to Throwback Thursday on Practical Machinist. You don't always want to be about old machines and old history. We want to talk about the modern day stuff as well. So we have the vertical CNC milling center that you saw. We also have 3D printing, and we noticed when people come in that the kids know a lot about 3D printing, but the parents don't know too much about it. So we try to educate both the parent and the child that 3D printing is here. It's additive machining. Everything that you saw in the museum is subtractive, and starting out with a solid block of material, cutting away until you get what you want. In 3D printing, you start off with air and you add material. So this is one of our, two of our 3D printers. We talk about how it's like going into the deli, slicing up a big piece of bologna, then putting all the pieces back together again. That we start off with a model in 3D space, send it through a slicing piece of software that cuts it into little slices, and then the machines put those slices back together again. So we do lots of different parts at different times, make all little things. A lot of the parts are given away to the kids as well outside at our gift shop and out front in the lobby. So 3D printing is here. Gussinger Automation was nice enough to donate a FANUC Robot to us. So we're in the process now of incorporating this guy into our everyday activities. We have a programmer that comes in on the weekend to help program it. But it's really a good addition to what modern day manufacturing is all about, and automation is taking place. We also are developing a number of hands-on activities to go along with the measurement display. This is the one for the scleroscope that we talked about, or the ball drop hardness gauge. So we're able to, someone will be able to simulate what it is. They're bringing the ball all the way up to the top, throwing the lever, and they can see how high the ball bounces on 3 different materials. So again, we're trying to incorporate hands-on activities to go along with the measurement display so that people get a better feel than just looking at the artifact. Little talk here is this large lathe, the granite bed lathe. But it's one of the first examples of V-ways that we have. It's 1825. It's one of the earliest machines. We're going upstairs to the offices and to the back rooms, but please be careful going up the steps. Practical Machinist will get an exclusive look at what's behind the scenes in the American Precision Museum. So what you're seeing is just another portion of our collection. What's out on display in the exhibit hall that you saw is a very small part of the collection. In this corner over here is paper documents from companies like Brown & Sharp, J&L, Jones & Lamson, all different documents and records, drawings, journals, advertising literature, all from companies up and down the Precision Valley. The next kind of block that you see here is our typewriter and sewing machine collection, which is quite extensive as well. Yeah, through here. We're in the middle of a massive project. We had somewhere around 150 boxes of books that go from early 1800s all the way through. Lots of textbooks, all different kinds of storybooks, history. So we've been going through them pile by pile. This machine here is custom built, and it takes the receiving revolver and puts the pocket in where the barrel goes. Oh, I'm sorry, where the cylinder goes. So there's two cutters that move together in order to do that. So a lot of these machines still date back to the 1800s. If you ever see a carpenter's square and you see all the divisions that are in the carpenter's square, this machine rack here actually etches all of those lines into the square at one time. It goes back, it comes forward, and scrapes right into that thing, into the part. There's steam engines from different eras. This big crane is from another company out in Pennsylvania. There's a coal digging machine that's also from Pennsylvania. This is a barrel reaming machine. The barrel of the gun would be formed, and they would run it back and forth in order to get the barrel smooth and straight. This is wooden framed, wooden pulleys, all on the same machine. What you see here is the beginning of a new display that'll be coming out in about 2 weeks or so, 3 weeks. We're bringing out toolboxes, and the whole conversation is around what's in a toolbox. And what you learn is that from the tools that are inside these boxes, you can determine what profession the guy was, whether he was an upholsterer, whether he was a machinist, whether he was a carpenter, whether he was a mechanic. So some of these boxes haven't been opened for 30, 40 years, so it'll be an interesting display. And you can see small tack hammers, and you see like small tacks and brads and things like that in the guy's toolbox. We like to put on short displays. This will only be out for about 10 days, and then they go back to the collection again. We just finished up one on typewriters and sewing machines, from stitches to letters. Last year we did an art show where we took out a lot of the mechanical drawings from the 1800s that we have, as well as some ads, portraits that came of founders like Fellows and Bryant that came out of their boardrooms that wound up here. So we did what we called an industrial art show. Prior to that, we did a miniatures show where we brought out all miniature steam engines and had them running and doing all kinds of good things. So we do a lot of pop-up displays, short periods of time. This year we're doing toolboxes. We're doing a video, what the spooky basement tells us, and then finally ending up with Steampunk Christmas here at the museum. This is perhaps one of my favorite machines. It's a universal machine, so it's a lathe, a milling machine, horizontal milling machine, drill press, everything in one machine, made by the Gilman company. More than likely, maybe it went on like a battleship or something where you need lots of different machines in a very small space. So this is probably one of my favorite machines in our storage area. This is a Etheric Force machine. It actually does nothing. Kind of was a scam. It was kind of a pyramid scheme. Oh, I'm almost done. I'm almost done. Can you give me more money? Can you give me more money? But it never did anything. It's one of what we believe are 2 left in the world, and this one might be the only one that's open to be seen by visitors. It's an Etheric Force, so it's supposed to be able to be like perpetual motion, but only perpetual energy, and it never really went anywhere. If you think about machinist scales, metal scales from Machinist, again, you have to put those etchings into the scale. This machine puts those etchings in very precisely in incremental form. There's a band here, and the way this band works, there's no backlash, so it's very, very precise in its positioning. And that's another unique machine. So this guy here is a very early hard drive. It was made here in Vermont, in North Springfield, Vermont, by rotating magnetic memory drum. And what it was, there's a gear inside, and they filled each segment between the gear with magnetic media, and then they turned it and trimmed it, and that's how they were recording with it. Early hard drive from a different angle. Everything you see here has been cataloged and traced. We know where its origins are. So it's part of being a museum as well. So that's our back room, one of our back rooms anyway. There's still 2 more stories to this building, but we won't go up there today. Let's see how we can get out of here. Well, thank you, Practical Machinist, for allowing me to take you through the museum. If you have any questions, you can leave them in the comments below, or you can reach me at steve@americanprecision.org. But please check out our website as well, americanprecision.org. We are on LinkedIn, Facebook, Instagram, all over the place.